Welcome everyone to the Bequant Network Optimization webinar. I appreciate everyone taking time out to view this webinar. My name is Michael Schubert. I am with Solutions for eBiz, and I'm going to be presenting the business side of things. We will have Jose Lopez, CEO of Bequant, going through the technical side of things, and then at the end we'll discuss pricing and have some time for questions and answers. So having said all that, I will dive into my presentation. So I'm going to provide a little bit of background about Bequant. Bequant started out in Europe in 2016, and they now have 60 plus installs worldwide. So they're not a brand new company. They're just kind of new to the US side of things. The Bequant founders previously founded a DPI pioneer company called NetSpira Networks that was acquired by Ericsson, and it provided the DPI functionality for their core network nodes. So again, the Bequant founders are pretty knowledgeable about the programming and DPI aspects to the internet services. Who is targeted to use the system? Again, wireless ISPs, fiber ISPs, cellular operators, enterprise networks, anyone who wants to speed up their network. As I said, the first quarter of 2019, which was just not too many months ago, we were introduced and decided to join up and promote the product. We have some happy and satisfied customers. Some of these guys you may recognize: Aeronet, Plains Internet, Genco, Splash Internet, NCoolNet, Cherry Capital. Of course, we're wanting to grow that. So the big question is, why do you want to use TCP acceleration product from Bequant? Well, first of all, it can accelerate your network performance by up to 100%. I know that sounds like a lot, but we do, in point 2 here, have reports that can show the measured performance gains. So we're not just selling you snake oil. We've got something that we are confident works. If you want to reduce your support calls on slow streaming complaints, this product will help you do that, and it's proven so far in the customer base that we have. If you would like some DPI features such as shaping and visibility, it has that capability as well. The DPI features are growing every month as they add new features. The really good news is you can get into this system with some inexpensive hardware devices that can handle up to 10G and even 40G. So you're not going to have to break the bank to buy the hardware to support this. The system is simple to configure and implement, and you don't have to integrate with the billing system. You don't have to integrate with any other third-party pieces. You can if you want to, but you don't have to get the benefits. If you take nothing else away from this this webinar, realize that if you don't believe us and you want to try it, we provide a free trial, no commitment, and no money down. So all you have to do is give us a public IP address for our management interface to be assigned. You put the device in line and try it out. And if you don't like it or if you don't think it works, you can send it back and you won't be out any money whatsoever. We're confident that the product works well, and we to date have not had anybody send anything back. So that's all the more reason for us to do this. On top of everything else, it does have an affordable monthly fee or a one-time license option if you want to go that route. As you can see, they are worldwide. They're not just in Europe, but Africa, Central South America, North America, and even a spot over there in Asia, and it's growing. Every month we're adding more customers. So just to kind of review real quickly what a few customers have said. So Plains Internet in Texas, they did an extensive amount of testing, and they got convinced that some of their speeds were improved by up to 100%, and that's a big deal. Aeronet, I don't know if any of you know Gino. He's done some presentations at Wispapalooza, but again, he was somewhat skeptical and he did a lot of testing, and he's got a very large network there in Puerto Rico, and he was a buyer of our system. Cherry Capital, Tim Malone, one of the WISPA board of directors, he had a network that was small, but had some performance issues, and we installed it, and he got the advantages of customers not calling up and complaining about performance. The other thing that's unique about him is he runs pre-seam, and he feels like it is complementary to pre-seam. So again, we do play well with others. Genco, one of our very first customers in the U.S., get the advantages of not having Netflix buffering for their customer base. So that's a nice thing for them. Splash Wireless, again, a smaller operator, but a guy that had no problem in getting installed, and his Hulu customers noticed an immediate positive impact. So all of these guys that we got here so far, they're getting advantages in different ways, but ultimately we got ways of proving that things are working better for them. So having said that, I'm going to turn it over to Jose to then go through the technical product description, and I'll be back to you at the end to talk about pricing and question and answers.
Thanks, Mike. Thanks to all the attendees for your interest. So our product, how do we optimize your network? First, as Mike was describing, we can accelerate the TCP traffic. We do this with TCP optimization techniques that I'll show you later on. We can also, using deep packet inspection, DPI, we can show the usage of your network by applications and subscribers. And finally, we can limit the speed of certain applications under certain conditions with bandwidth management. So when we say that we accelerate, we mean that we increase the speed experienced by your network users, which is not the same as the speed that your network provides them. Let me explain. If let's suppose you have a subscriber, and at a certain point he has a network that could go at 10 megabits per second, and maybe that's what he can measure with a speed test. But if he's watching Netflix, and Netflix is going at 5 megabits per second, 5 megabits is what he experiences, and that's what he thinks this network is giving him. What we do is to, in these situations, which as we'll show are quite common, we can get the speed at which Netflix sends to be closer to the 10 megabits or whatever is the actual capacity that could be attained, and so in this way reduce the unused capacity. So of course the next question is, why would Netflix send at 5 when it can send at 10? Well, the answer is transport protocols like TCP or UDP. TCP is the main one. It's used by more than 80 or 90% of applications in internet, and it is software. It's a protocol. It's a software that's running on both sides of any communication. But the main one for this is on the server. So in the example before, this Netflix guy is connected to a Netflix server in some data center from Netflix, and in that server, the TCP part of it is deciding at every point at what speed to send. If it sends too fast, if it sends faster, in this case of 10 megabits per second, those there'll be a lot of packets lost because they cannot fit into 10 megabits per second. If it sends at 5 megabits per second, it leaves capacity unused. So what TCP does is usually start slower speeds and then ramp up and see, probe at what capacity, at what speed it can send, and then try to find that optimal speed and stick to it. Normally the TCP can do this quite well, and that's why, in fact, the internet has worked really well for everybody during these years. The problem is that if in the past there's a wireless link, and nowadays with Wi-Fi, that it's almost always, or if there are packet losses, or if the server is very far from the client, TCP, when ramping up, many cases will see variability coming from the wireless part or packet losses that it will interpret many times as a sign of having reached congestion, that having reached the speed limit of that path. And so it will stop ramping up and will then be sending, in many cases, slower than it could. And this is where we can help. And when it is TCP, if you in your network put one of our appliances in, so that somewhere in there, when we can discuss, of course, with each one of you what's the best place, but basically it has to be a place where all the traffic goes through us. And then the TCP part will optimize. The other, well, we just let it go through. An effector will just measure it, and maybe if you want, we can limit some of it, the speed, but mostly just let it go through. And the TCP part, we accelerate. And how do we do this? Well, what we do is not magic. What we do technically is called transparent TCP proxy, and it is something that's been done for over 20 years in many networks. For instance, all satellite networks are using this. Without this, they would not work, basically. And large cellular networks, like in the US, Sprint, AT&T, they have this in their networks. They've had this for years. What we've done is to make this now, this advanced capability available for smaller networks. And so let me show, the key to this is not so difficult if you see it. So let me try to show with this animation. Imagine we have these two servers on the right, and they want to send 7 packets. Okay, this is just an example. So these TCP, what we'll do is send 1, 2, 4. Just to probe the capacity. It will be sending more and more. Okay, and so now with these packets, they will go out to the clients, which are here on the left. Okay, and when the clients receive the packets, they will send back acknowledgement saying, "Oh, I received that. I can get more." Okay, so on the top we have a direct path without any proxy in between. 5 seconds as an example, and we stick one of our proxies, one of our devices in between. Okay, between 2 and 3 seconds as an example. And now we'll count the packets to see why it is faster with a proxy like that. So when the download starts, the first packet, the first round gets to us, we send back an acknowledgement as if we were the end user, telling the server that we got that packet right. When the server gets that acknowledgement, then it sends the second round. And this second round, we will get and store in a buffer, which we build for every connection. And now when the real acknowledgement from the client gets to us, we already have that second round, so we can send it right away. And in this case, for instance, we are gaining 4 seconds over the top path. And so same thing will happen for the next round. Okay, so in this case, if this on the bottom is 17 seconds, it'll be 8 seconds more up there. It's just basic maths in this case as 25 seconds. Okay, so what's the key here? The key is this buffer that we are building here. Small buffer. We only need to have there 1, 2 rounds of packets, just so that the end customer, the client, feels that the data is no longer in some faraway server. It's now the data now seems to him that it is in your network, and being closer means being faster. That's the key in all communications. But not only that. Imagine there were any packet losses here in between our node, and as it can be in any wireless network anytime. TCP has no problem in principle with that. In those acknowledgement packets, there will be information that it's missing some certain packets, and then the server sends them again. But if we are here, we take care of that, and so these retransmissions will happen much earlier, and so again faster. And finally, the other mechanism by which we accelerate is that when we do send things out. We send them with our TCP that we have designed and worked on for the last 7 years, and we have patents, and basically it is much better than it works much better, especially with wireless networks. In finding this optimal speed. When ramping up, as we were doing in this example, 1, 2, 4, then 8, 16, or whatever, you know, at some point, if there is a lot of variability here, this server on top will decide, oh, okay, I've reached the speed limit, so let's stick to this speed. And in many cases, statistically, it'll fail and get a lower speed. Okay. However, we can do that better. We can get to, we have algorithms that are not fooled by the variability in wireless networks. And so we can get to that speed in a more precise way. So how do we see this? Well, this is we are deployed as Mike said, in over 60 networks worldwide. And when we are deployed, we always leave a small percentage, around 1% of all TCP connections that we get through, we leave them without any optimization. Okay, so we just let them go through and measure them. In this way, we get a lot of downloads that are not optimized, and we can measure them and compare them with the rest, all the 99%, the rest, which are optimized, and see the speed difference, how good we're doing. And so, for instance, if we and here there's the examples from 12 networks, very different kinds of networks. We accelerate different amounts in different networks. But we always do accelerate. So, for instance, if we look at this fourth case, for instance, this wireless ISP, in gray we have the average speed measure over, I think this was a period of a week, and we just stick to Netflix to stick with this example. Okay, so the average speed at which Netflix sent in this network, in these 1% of unoptimized connections all the time, was 1.04 megabits per second. But at the same time, all the other downloads that were happening from Netflix that were being optimized, they were going at an average, again, there's thousands, well, hundreds of thousands or millions of downloads over a week. They were going at 2.55 megabits per second average. So for some reason, and the reasons that I just mentioned, Netflix was sending at this average of 1.04 when it was possible to send at 2.5, because we were sending at 2.5 megabits per second. So there was room, that there was no congestion. There was it was just that Netflix, like other applications, in fact it's TCP, they were sending slower. And so this is how we can help, because in this network, nothing had changed. All the radio, all the infrastructure is the same. They just had our node in between. And basically their subscribers were now watching Netflix better, because if you get, I mean, the ones that were already watching it better, of course, maybe they just got better resolution. The ones that were just on the verge with not very good quality, now they're no longer having rebuffering and all those problems. And this is not just Netflix. It is, in fact, anything that uses TCP, which is basically most applications and internet. In fact, let me explain you, for instance, this is something that you will get from our node in real time. It'll be a measurement of the mean speed, the average speed of all the TCP connections happening in that network. Here we see the picture over a week, okay, with 7 humps there, basically. But in comparing how fast it goes with and without acceleration, we classify the results into different categories. Because, for instance, we show the ones that come from servers that are close by, which is, for instance, this first column, and then separate them from servers coming from very far apart, which is the column on the right. Why? Because they go much faster. Downloads go much faster when they come from nodes that a data center from Netflix that's very far, very close by, compared to other that's maybe in another country. And same thing, we cannot compare. It's not the same what you can get from small downloads than what you get from big downloads, which are usually faster. So in the top row, we have the small downloads. Here the medium downloads from 100 kilobytes to 1 megabyte, and here the larger ones, which are larger than 1 megabyte. Okay, so in this case, for instance, if we look at this on the left bottom, we have that on average the speed, the TCP speed of all application downlink, because you can also see that this uplink was in that network around 5 megabits per second, whereas with us it was up to close to 14 megabits per second. So what else can we give you? We can also see the traffic as it comes through and tell you what's the, break it down by what applications it comes from. We can, for instance, in a network, you can see in this case that there's this much YouTube 25.8, Netflix, PlayStation, Instagram, Google, and you can see all the details from all the others. And not only that, we can also show this in over time. For instance, this is in a one network. This is a fairly big one. It has up to 14 gigabits per second at peak, during peak times, then going back down to 2 gigabits at night. But in this case, and this was, for instance, you can also see, well, a couple of days ago at 10 p.m., this was the breakdown, because at different times, maybe how it is split is slightly different, because some applications are more common at certain times of the day than others. So this is just showing you how much of each of type of traffic you get over time, in this case, over 3 days. Okay, so this is another information that will maybe of use to use, because for instance, you can see if you have to improve maybe the peering with some providers of certain contents that may be the more popular in your network. And now the last thing that we can do, okay, if we this is about the how to limit the speed of certain applications, because, well, if we go back and see what the split of the kind of applications you have in any network, what everybody sees is that video streaming is in fact the largest category in most networks. Netflix, YouTube, Hulu, Instagram, all these are the biggest volume in almost all networks. And that's not bad, in the sense that they have a peculiarity, which is that if they nowadays use a technology called ABR, which is adaptive bit rate. When Netflix or YouTube send data to you, the client is all the time measuring at what speed the network is going. If it's going fast, it'll send at very high resolution. If it's going slow, it'll send at a lower resolution. And this lower resolution means at a lower, it will use less volume of data. For instance, this is an example we did with a 2-minute Instagram video stream. That the same one, it was a guy surfing for 2 minutes, and without any limits, it was 24.8 megabytes. If we limited it to 1 megabit per second, then it was only 4 megabytes, 7 times less almost, 6 times less. But of course, the quality was not very good. However, if you just limit it to 2 megabits per second, then the quality on a cellular handset or a tablet was not too bad, because it was around 480, 720 points, not bad at all. You would not complain. However, you would complain if you had like a big TV set, but not so much. But if you go up to, if you just limit to 4 megabits per second, then not even with that would you complain. Just it would be the quality would be almost full HD. So and the volume used would be about half. So we can use this because if you did, if you limit the speed of email, for instance, an email download would just take, if you limit it to, instead of 30 megabits per second, you limit it to 4 megabits per second, it just means it will be 7 times slower, right? But the attachment that someone is downloading is the same size, so you only get the user, a little angrier. But however, with this, you can still have the user relatively happy, because they can have full HD, and the volume in your network be more under control. So we have done this, for instance, in this network, we did this in which during 4 days, even hours, we limited only video streaming, all video streaming, but only video streaming to 4 megabits per second per user. Okay, so all the video streaming could only use whatever it was up to 4 megabits per second. And then we did this on even hours, and then odd hours we just let it without any limitation. And in this graph on the left, bottom left, we have every hour the traffic. Okay, and in gray it is when there's no limit, and in red is when there's a limit. And so you can see how the volume, the throughput through the network goes, well, especially during the peak times, can go up significantly compared to having the limitation. And I can also say that in this, there were no complaints at all from this limit of 4 megabits per second. So the result of having this basically is that the peak usage is going down by 15%. Maybe the overall is going down less, but you can in fact, and we allow you to do this only when, for instance, the network is going above a certain, a certain throughput, because maybe at night you don't care, because there's an ample capacity for everybody, and then you don't want to limit. And in fact, you can do this, not the quality, the overall quality of the network, by limiting somewhat some of the users, can in fact be much better for everybody, because we were measuring, for instance, at the same time during that test, here on the right, the average latency, and it went down by 5 milliseconds. So that means that and that makes sense, because these streaming applications many times tend to take all they can, and then that raises latency. Okay, so this is how. So in our system, it's very easy to configure this, because all you have to do is first select all the applicable domains, the applications to which you want to target. We already, now we have added the possibility that you have a predefined sets of domains. You don't have to find out which domains. We have predefined sets for streaming, or for instance, Microsoft or software app, or Apple software updates, things that might make sense to limit. And then you decide to which customers you want to apply this. It's maybe by IP address or by VLAN tag, and then you also decide when you want to do this, because maybe you don't want to. In this case, you only want to do this limitation when the network is going at more than 800 megabits, for instance. And then you set the speed limit. And you can have several of these policies, we call them. So we think that this is something that can then again give you better quality of your network, because in fact, I mean, there are other applications that can do this, what is sometimes called QoS or limitation, but it's a bit different. First, we can do this with a much higher quality. Why? Because we can do this without dropping any packets. Because with TCP, with those acknowledgements that I talked about that we send to the server, we can tell exactly at what speed it can go. So we can do this limitation without dropping any packets, and that gives you a better quality. But not only for that, because then we are doing this in conjunction with TCP acceleration. So we're still accelerating all those downloads that may be happening, that are going at too low speed, maybe less than 1 megabit. We are getting those to above 1 megabit per second, maybe. So we're helping those in problems, and we're just limiting when we want, and not all the time, as I said, maybe not necessary. We limit those, and then up to a limit, we get them up, but maybe the ones that are at 5, we could get them to 10, but we just leave them. The ones that are going at less than 4, for instance, we just let them at 4. We don't get them up to 8 megabits per second, because probably they wouldn't really get that much better quality, but your network will be running much smoother if everyone, at certain times is using just what they really need for a good quality download. So, and we think that the price is very competitive. And this, in fact, works with other network management products. Like, for instance, we have a number of customers that have a pre-SIEM, and they are pre-SIEM sits after us, and they do all the limitation of the how much speed for each, the total speed of each user. So we can work with others fine. And so, having described what we do and how we do it, and I now get it back to Mike to talk about the more business issue.
Okay, thank you. All right, so here's a view of the devices. On the left is a super micro. On the right is another super micro. And again, these devices are able to handle some pretty good speeds and work well.
Mm-hmm.
So on the equipment pricing side of it, those two configurations, one of them is about $1,500, which is the one that was on the left, which handles up to 10G. The higher volume equipment kind of costs between $3,500 and $4,200. It depends on how much memory you need to put on that to handle the load. Both devices can handle fiber as well as copper, so you don't have to buy a different device as you move from one end of the spectrum to the other. The software is the same on either device. It's, as said before, it's a one-time charge or a monthly fee. The monthly fee starts at $304 for 1 gig, and then it's discounted from that point on as you add other gigs. The price is based upon the amount of bandwidth you're flowing. And if you got further questions on pricing and all the different plans, you can click on that link and see more about it. Okay, so I think that brings us to the summary. Essentially, why Bequant? Well, we want to optimize the speed. We want the network users to have good experience. We want to analyze the traffic, and we've got a competitive pricing scenario, and it's easy to configure. So all of those in summary are why we want to keep looking at Bequant. So I think with having said that, I believe, does that take us to the question and answer period? So I do have some questions here. First question, Jose, what is the effect of your equipment on the results obtained from speed test sites?
Okay, yes. Well, speed test, we, in some of the cases that we mentioned before, we can improve speed test results. Probably is not the application that we improve the most, because speed test, let's say they do some tricks in the sense that they are measuring really the speed of the network, sending many times open, like 10 or 20 connections at the same time. So it is, they, in some ways, by getting the link into congestion, they manage to get out of all the problems that TCP has when it works in real applications. Like, for instance, the Netflix will open three connections, or YouTube 2, 3. So they are a special application. But when the network, in many occasions, we are also getting an improvement. And but the best, as you were saying at the beginning, is that that with the free trial, you test it out in your network.
Okay, thank you. All right, does it accelerate encrypted traffic?
Yes. It's for us. Encrypted traffic, HTTPS, what is the basis of internet, TLS, all that goes on top of TCP. So when we store things, we don't see anything inside them. We just for us, they are just bits, and we don't need to see anything inside the encrypted TCP. We just look at the domain name that comes unencrypted at the beginning of even TCP sessions to tell you about what kind of traffic it is. But apart from that, it doesn't matter to us if it is encrypted.
Okay, thank you. Has it been tested on a PPOE network?
Yes, we can work on top of PPPoE. Also, we can work if you have VLAN tags, and we can work if you have MPLS tags. We just go up the protocol stack and get to the IP part of it.
Okay, all right. is the installation configuration complex?
I don't think so. It's usually, for instance, in fact, for the trials, what you were saying before, if you tell us your IP address, the IP address that you would use for the management, basically, we will just set it up, and then we work at level 2. We don't use any IP address we just need two ports. We have 2 ports, or 4 or 6, couples of ports. Whatever you put through one port will come out of the other port, and that's the data plane. And so we'll send you the machine configure so that you just stick the 3 on the 3 ports, one the management one with the IP address that you gave us, and then the 2 other ports, and it'll just start working. So it's not really very much configuration at all.
Okay, thank you. I know we didn't address this, but the question is, if it crashes, does all traffic stop? I know we have specific recommendations on bypass options. You might want to cover both those.
Yeah, yes. I mean, as I said, we are just like a bump in the wire. We are, you put one port in and then one port out, and whatever comes through us, we put on the other side. Okay. So then, like any link that you may have, what we always tell our customers is to set up a bypass link in parallel, so that if it is with MikroTik, you have the active backup links. If you can do that with LACP also, with you can do that even with IP level protocols, so SPF, PGP, any way that you would do in any network, so to protect a link, so that if a link fails, the other one takes up. That's what you do with us, and that's how it is set up, so that basically if you need to put us out for maintenance of the equipment or whatever, you are protected. And since we have this transparent TCP proxy, you can put us out of the network and the connections will continue. So it's the safe way to have this bypass link.
Okay. What are the specific improvements to a fiber network?
In the fiber networks, we work just, I mean, TCP is the same, of course, but in what we've seen in TCP, contrary to what you may think, in fact, the acceleration we are getting in fiber networks is higher. Why? The thing is that we can go high, we can accelerate to high, fiber networks allow you to get to higher speeds, so we can then accelerate more. It's true that since they are already probably getting a better speed to start with, this acceleration, while it is there, may be less noticeable to people that may be already, if you already have 25 megabits per second and you can watch 4K, if I now with this you get 50, you will not see, I mean, you will get that, and of course there will be less rebuffering and things like that, but it'll be less noticeable than when you are improving from 0.5 megabits to 1, because with 0.5 you cannot see Netflix, then with 1 you can. So while we so the thing is that we accelerate even more many times, but again, test it, see it. Some of the results I showed before were with fiber, and but it depends on each network at what level you are right now.
Okay, thank you. So I had actually a couple, 2 or 3 questions submitted that are similar. I think I'm going to describe it this way. The difference between DPI and TCP acceleration, the product can do one or the other, or you don't have to do both at the same time. Is that correct?
Yeah, well, the product is designed to do both at the same time. Okay. So that, for doing the limitation of the speed, the DPI, DPI has deep packet inspection. One part of it is just being able to identify things. So that's one thing that has nothing to do with speed. But then once you've identified this product, this flow as certain type of traffic, and you want to apply a certain kind of limitation, then for TCP, we do it using the what TCP lets us use, which is a much better way of reducing the speed or limiting the speed, because you do it without losses. And with UDP and all the rest of IP traffic, we do it the standard way as everyone else, with a buffer and then just limiting the speed. So in principle, they work in conjunction, and we think that in fact is the good way, because you know, you still help the ones that are having very low speeds, which can happen in any case, even in the worst the best connection, the best you know, household where you have a great fiber connection. Then if someone has a Wi-Fi in the basement, then it really has a bad connection even. So we can help those. And then have the limitation click in just when it's needed.
Okay, all right. Can the Bequant DPI analyze the use of a specific user IP?
Yes, it is one of the latest things that we have included in our latest version, that just as you can see the picture for the whole network, how much you can then configure certain users so that you track them, let's say. And for if you have like a user that has problems and is calling you, you can track that guy for a day, and then next day you'll have the possibility to see exactly that same picture, but just for him, and then analyze out of that what problems he may be having and what speed he's getting with the different applications during those 24 hours, whatever.
Okay. As far as the let's see here, the trial side of it, I had a question about, you know, one-offs of, yes, you can not do the monthly fees. There is a perpetual license, and you can avoid the month to month if you want to do that. Okay, let's see. I think there might be a couple more come in here.
Yeah, I think that the only thing about the only comment to that is that when you buy the one-off license, you get the support included for 1 year. After that, you have to pay 5% every year if you want to keep the support. And the support, for instance, apart from new versions and new functionality, which we keep adding all the time, it gives you also, for instance, the access to, we keep updating these DPI signatures to identify different kinds of applications. So because support in the monthly thing, it's already included, of course.
Okay. What happens if my throughput exceeds the license? Is traffic blocked?
No. The way we enforce licenses is that if you have, for instance, a 10G connection, and you have a 1G license, so if you go faster than during peak time, maybe at 1.5G, all we'll do is that basically 500 megabits of your randomly will not be optimized. We will just let it go through without limitation and without optimization acceleration, but you do still get optimization with 1 gig that your license gives you, but we will never cut the traffic.
Okay, all right. Well, we have reached our time limit. We had a 45-minute window, and so I appreciate everybody, all the good questions. We will be happy to answer any other questions that we haven't had time to answer. Just contact us. Ideally, we would love to see you sign up for a trial. Just contact me. My contact information is here at the end of the presentation, and I appreciate everybody for showing up. Thank you.
Yeah, thank you very much. And you can also see us at WISP-Palooza, where we will both be with our booths, and so that will be on another opportunity to talk and discuss if you like. So thank you very much to everybody.